point to check out the chat. But otherwise, yeah.
Sounds good.
It's 12:06. Shall we kick off?
I think so.
All right.
Cheers.
Thank you, Kate. Well, welcome everyone, and thanks to every one of you for coming to the forum, to the brown bags today. And thanks, Kate, for setting this up. So my name is Anna, and I'm a data scientist at Eliiza. And today I will be talking to you about our tips and strategies that we use in order to automate data extraction from documents. And before I get into the juicy part of the talk, I would like to mention what I mean when I say that we extract data from documents. In particular, what I mean is that we would like to extract the text, and I'm not going to talk about images. So I'm not going to talk, for example, about detecting an image on a photo. And we are going to work, and I'm going to tell you some tips and strategy to extract text that then we can use in order to perform some downstream tasks. And before I give you, for example, some examples on how we use this in Eliiza, I would like to mention, well, why do we need to automate this thing? And I'm sure a lot of you might already have some ideas. These are mine, and I'm happy to discuss them with you later if you like. So first of all, whenever we can reduce the burden of those tasks that are repetitive, probably also boring, and they are also not the main task of our job or of our client's business, for sure, automating would be an option which could improve our task process. The other reason could be, especially now, if you think about the world we are living now with social distancing, having sort of like shifting towards sharing information in a digital way instead of using paper documents, make things more trackable and also avoid the need of having human-to-human content, especially also exchange of paper documents. And next, of course, if we automate something, it means that we can smoosh the edges of our tool in order to increase the speed and the efficiency in those tasks, again, which are necessary for someone's business, but they might not be, they're repetitive, and they're not also the bulk of what we have to do. And finally, if we automate something, it means that we can standardize the extraction and the output in order to reduce human error, which might vary. It might be more variable during the day, during the week. This is not to say that the machine won't have any error. So the automation will still carry some error. It's not going to be perfect. And this is something that I won't touch on today, but it's really important to keep in mind. And this error will be either systematic or probabilistic if the method that we use to extract the data is based on rule-based, for example, if this then do that, so a deterministic way of doing things, or if instead we build a model and then we will have to deal with model biases and all those sort of things, which is not going to be what I'm going to be talking about today, but keep that in mind. And I'm going to now show you, before I tell you our strategies, I'm going to show you examples of situations where we use it in Eliiza. So they are not exactly examples from Eliiza's project, but they go really, really close to it. So say, for instance, you are an insurance company and you receive thousands of receipts because you need to process them to then for insurance claim for the customer, for your customers. Really, the only thing that you need from this receipt and from this image is to extract the item and the charge. And then you can use the charge in order to process the claims. Another example could be, say that you work in a financial institution and you need to provide customers with loans or mortgages, and a customer applies. And before you can do that, you need to prove their income. And you can find, of course, all the information regarding income on the payslips. Here I'm showing you two payslips type, which normally the customer will maybe submit by an email or as a scan. But the information that you have on these documents, even though they are both payslips, is different. So maybe the gross pay in payslip type 1 appears right next to the total earnings keyword, whereas in payslip 2, we have that instead the gross pay appears in this table format. And this, of course, makes things complex because if you can already think about it, it's hard to have an overall general way of extracting information from payslips since they are different. Another example is for pay period. So similar thing, sometimes it's on the right, sometimes it's on the left, on one line, on two lines, and so on. Another example that we had to face at Eliiza, for example, is to detect specific documents on a page and then extract the information from them. For example, if you need to report on some cybersecurity breaches, if you need to prove identity of someone. So here the aim will be to first detect what template, what type of personal document is there, and then get all the information like the address, the date of birth, the name of the person. And generally, I think about information, automating extraction, whenever information is in a format that we can, in a sort of standardized format that we can automate. And here I've got this story from my childhood. My mom is an accountant. She's still in Italy. And I remember every time during tax period, she would come home with hundreds of printed documents, usually not even handwritten documents, just like printed. And then she had to go through all of them and extract the information and that do whatever she had to do. And I had to help her a lot with that. And when I told her about this project at Eliiza, she was like, oh, I actually wish we had something like this. Of course, there's always a cost benefit, but there's always benefit in thinking if this could improve something into the processes that we have to deal with. So going to what I will discuss today with you. First of all, I will share with you what the common optical character recognition engines that I've been working with. I will be using this word OCR a lot today. And following, I will talk about what are the limitations of the current OCR tools. When I say limitations, I see it more as like what we found was limiting our projects. And then I'll talk about some strategies to extract targeted information from a document. So that when we really need to target a specific template or tackle a specific problem. So common OCR engines that I've been using are these three. So there's other ones that I'm going to list in a second. And I put them in order of the one that I've used most to the one that I've used the least. So Amazon Textract can be run from the Amazon Web Services console. And there is also a Python package, Boto3. Boto3 is actually a general Python package, a software development kit to access a lot of different AWS services. And within Boto3, the client class contains a lot of the function to run Textract, so to run the OCR engine of Amazon. Within Google Cloud, and I'm going to go into more details in a second, there are the Document AI services. And of course, Amazon and both Google and Amazon are paid services. And the Document AI services can be, so there are services to analyze and process document. You can run them from the Google Cloud console. There is also a Python package again, Google Cloud Document AI, which personally I haven't used yet, but there is all the documentation on how to, I've linked here how to get started and how to set it up. And finally, I would like to mention Tesseract, which is among the three free and open source. I've linked here the command line package, the GitHub folder, as well as the Python package. I've only marginally used Tesseract for my work. However, if you want to give it a go, you can even do it right now. Like, it's totally free. You just need to provide a PDF or a PNG image, and then you can try it out. Just to mention, like both the Google and Textract services, they allow different file formats. So, but in general, both JPEG, PNG, PDFs are, you can use any file type. On their website, they will have specific file type things, but you can generally use all different file types. There might be different function that you need to use. And just for completeness, I would like to mention other available engine. So here I'm linking, I put a link to a blog post that I've read to know more about OCR tools. And in this blog post, it's quite interesting because they use different examples and comparison to go through all the different pros and cons of the different tools. And in particular, they mentioned this other one, which is called Abby Fine Reader, which I haven't used on, which apparently is meant to be quite good for handwritten documents. And then there are all the Azure OCR services, which again, I haven't used, but from what I read, and they look pretty similar to the services offered by Amazon and Google. And this brings me to show you how the extracted text might look like. So here I'm in the Eliiza the account in the Amazon console. I've uploaded document here on the left, which is this payslip here. And I'm running, TextChart is run, and this is the basic sort of information that you get, a bag of words with no structure. Sorry. You can also go more fancy, and TextChart also allows you to extract and detect tables in the document. One thing that I like to point out, for example, how this table was extracted. Well, it probably is not doing the best job because, for example, this part here, it's split it into 4 columns, even though it's probably not part of a table. And also the total earnings, it's split it from its value and it's appearing within the net pay chunk. So as I'm coming back to this later, table are more, so extracting table is more expensive, and you might need to think or ponder if it's really what you want to go for. It's 10 times more expensive than the basic raw text. And then you will have the forms. So similar to tables, it's 5 times more expensive than table extraction. And what TextChart is trying to do is to find a form-like structure within the page. Probably this is not the best example, but that's sort of the idea of what it will give you in output. Talking about the Google Cloud services instead, so I mentioned the Document AI services. So Document AI is a set of services to analyze, perform different things with documents. And in particular, for example, the base OCR will allow you to extract text, raw text, and so on. So it's like the basic structure. Then there will be, there is a natural language processing service to do more complex modeling stuff with the language, modeling sort of query with the language. And then the form parser is sort of like the Amazon TextChart equivalent. So it will give you the text as well as where the text appear on the page. You can try yourself for free to this link that I've linked here. The invoice parser is sort of similar to the form parser, but has been trained and meant to have really good accuracies for invoices in particular. And then there is this Document AI service within Document AI. So Document AI is also an API to access all the services within Document AI. So it can be confusing, but that's sort of like how it's built. And this is how it looks like. So I've run Document AI with the same payslip from the Google Cloud page for the Document AI page. And here I'm showing you like the payslip, all the text that has been extracted, and the OCR text here. Similar to TextChart, it can return some key value pairs identified, some tables extracted, and this JSON file, which I'm going to come in a minute. So I would like to provide a sort of like overview summary of these tools, and in particular the ones that I've tried. I'm not going to touch on AB, Fine Reader, and Azure because I haven't tried them myself. But according to, if I looked at these 3, for example, all 3 tools will provide you with some functions, both the text and the location of the text on the page. How they do that instead of like the quality, I put here red for bad or acceptable or good. I found that Tesseract, the way in which it provides the output, maybe because it's the one that I use the least, I found it less intuitive or less clear or less complete than the other two. But it still will give you both text and location. Tesseract doesn't do table detection from a page. However, as I've shown you, the other two documents, I haven't shown you for the Google service, but it's not always perfect. So you need to be careful. And to evaluate the quality of table extraction, it's another thing. Like it will be a complicated thing to do, which we are looking into that, but it's something that still is not definitely not solved. Handwriting. So Tesseract I try with is not really good in detecting handwritten text on a page. I have used Textract and Document AI for some handwritten documents, and Textract was doing okay. Like it all depends on how strong is the ink on the page or how good is the handwriting. So it's okay. It can do it, but I know there's been a recent release, probably a Textract release in the past month or two, which aiming to improve handwriting detection from documents. If you provide a rotated page, a rotated document to Tesseract, for example, a document written in English, it won't be able, I mean, for me at least, it wasn't able to detect the words. It was detecting the words as being written in Cyrillic or Japanese because they were all tilted. Whereas if you give a rotated document to the other two, you will find the text okay. What I mean with detects page orientation, maybe I should have written returns page orientation. So in theory, both Tesseract and Document AI should give you in outputs the orientation of the page. So if the page is straight, it will say page up and there's no angle to rotate. If the page is rotated, it should say maybe page to the left. However, when I try with some examples, it wasn't really doing very well. So yes, the feature is there, but it wasn't working as expected. Again, Tesseract is free. Here I'm giving an idea of how, to run Textract, it will cost 1.5 Australian dollars. Oh, wait, I haven't checked. I think it should be Australian dollars, but I might need to double check. Maybe US dollars, per 1,000 pages for the first 1,000,000 pages. And then it becomes slightly cheaper. Whereas Document AI is the most expensive because by default, I think it offers a lot of the other form and invoice parsers, so it's more expensive. So I hope I gave you a sort of like overview of what are the common OCR tools out there and what they do. I'd like now to talk about why I'm saying limitations. So mainly when I think about limitations, I think about general versus specific problems. So the available OCR engines, they try to solve general problems. So extract all the text, do the best in extracting tables or forms. However, table and form, for example, are useful, but often, as I've shown you for a payslip example, they might not be problem specific, maybe different clients, different projects require different form types, and the cost is not really worth it. And they're more expensive. So often we found that we had a need to tackle specific applications for our projects. So we wanted to be really accurate in specific document type, for instance, in order to extract and report only on specific known fields. And before I go into our strategies, maybe I'd like to see if there's any comment in there. In terms of this, no, I haven't used Camelot or Excalibur. No, I haven't looked into those. Thanks for the suggestion. Yeah, I didn't know them. I will take a note for that. Thanks, Carla. Okay. So this brings me to the second part of my talk, which is, or the third part, which is strategies that we sort of thought about to extract more targeted text from a document. So before I tell you the strategies, so this is the idea of what the data that we have. So we have an input document, imagine I've run text track, and I get some output. I get some CSV file, like key values and tables. But again, I've said I haven't really looked too much into those. I've mainly been working with the raw text, either just the words or this API response JSON file, which I'm going to discuss what's in there. So the JSON file contains the text, it gives you, and this is the same for both when you run the basic Amazon text tract or when you run Google Document AI, it gives you a JSON file which contains the text and the location on a page. So all these red boxes represent all the text and the location which text tract was able to find on this page. And the JSON is basically a long dictionary where every block of the dictionary contains some block types. In this case, I'm showing you an example for this block type line, which contains the words payslip 4. It gives me the text and the confidence of the OCR extraction. And then it gives you the location on the page. So the location is a scale location where the X and Y coordinates are scaled between 0 and 1. And then it gives you the hierarchical structure with the words that it contains. So for example, here I know that this block has 2 children, which are identified by these 2 IDs, and these 2 IDs will be somewhere else in the JSON file. Awesome. So what do we do with this? So say, for example, that we only care about the text and we only would like to use the text. So if we only would like to use the text, for example, you can imagine of building some natural language processing models where, for example, you might use just the words on a page in order to detect specific document types. So we have been doing that at Eliiza, for example, to tag specific documents like passport or the travel license. So you can imagine having your documents, you run some OCR, you get the cheapest thing that you can get, you just get the text. You can build some models and exploit, for example, already existing Python or other packages like Spacy and Flare, which contains models for different languages. And then you train your model so that it is able to detect specific document types. But then, of course, our aim is also to extract information from the documents. So, and also because from the OCR gives you both the text and it gives you the spatial location on the page. So, for example, Python as well offers a lot of different packages to work with text. Here I'm only listing 2, which are the ones that are, for example, used for string matching, like the fuzzy wuzzy string matching. So fuzzy wuzzy will search will either do perfect matching of strings, but it will also do partial matching based on the Levenshtein distance between 2 strings. Here I'm mainly talking about Python and strategies using Python because, as I've shown before, a lot of the OCR engine have already packages that are able to access them using Python. So that's kind of useful for us as a consistency with running the OCR and then doing more processing on the output. But also we can use all the spatial packages in Python. For instance, I'm going to mention 2 here because these are the one that I'm going to talk more about later. One is GeoPandas. GeoPandas is a Python package which extends the Panda data types and in particular the data frames in order to allow geometric manipulation remaining within the data frame structure. And GeoPandas uses the shapely geometric objects in order to allow manipulation of the polygons that you can find, that you can have in your data frame. So shapely is sort of used by GeoPandas. GeoPandas is sort of like a mixture between using the pandas data types with the shapely geometries. Awesome. So this brings me to show you an example, for example, how we might apply, text search and a spatial search on the page to achieve our goals, to do what we want. So again, I'm going to use other examples soon, but here I've got my I have my payslip, I run an OCR, I get the text boxes and the location. And for example, I'm going to query using a fuzzy-wuzzy, a string matching search, and I'm going to say, find the text blocks containing the keyword payslip. And this, for example, will return this payslip for chunk. And then I also ask, well, now detect the block, which is spatially closest to it, but also below it. So this will be a key value pair where the value is below the key. And so you can imagine this sort of sort of deterministically creating orders in order to navigate the space in the page. Of course, this requires that you have a knowledge of the template. And a lot of the things that we have done is more like based on what we know about the template. For instance, imagine that we have detected using an NLP model, we detected that there is a passport on the page. You can imagine combining different semantics as spatial searches in order to extract information from a template. And this is just showing you a very simple example where, for example, this read file function is a function which will run the textract or the Google Document AI engine, and it will parse the JSON file. And then this extract passport details combines several semantic and spatial searches to extract the fields that we want, and it gives you all the information on the passport. And within Eliiza, we've actually, since we've done this project several times, we started to build a Python module, which we call Thea. Thea was the goddess of sight in ancient Greece, which sort of combine all these different logics and different ideas. And however, what I would like to say is that, well, most of the times, the world is not straight. So often we do get, projects, or the scans are, when you scan a document, you scan it more tilted, the page is rotated. And if I would simply run the same function, I would get fields which are mixed up. So for example, in this case, name and date of birth are wrong. And this is because the above-below relationships won't hold. In theory, I thought, textrat gives you the boxes, as well as Documenta gives you the boxes, as I was showing here, a little bit tilted. So can we adjust before doing the query? Can we adjust the rotated geometries before doing this query? So what you can think of is, for example, as I was mentioning before, GeoPandas offers a lot of the spatial function, which can be applied to set of polygons. So there is this method called rotate. So rotate will take in input self, which is just a set of geometries, shapely geometries, an angle that you want to use to rotate, and an origin. So it's like the centroid around which you would like to rotate your set of polygons. Awesome. So now we need to find this angle and this origin. Well, this is sort of like an easy example because we can see that all the polygons are rotated with the same angle. And that's often the case because they all belong to the same documents. Of course, it's not always the case. Sometimes the passport has an inclination, a direction, and then the driver license on the same page will be in the other direction. So that makes the search of the rotation angle harder. And maybe we haven't quite solved that yet, but I'm gonna remain for the moment in an easy setting. Another complication that we found is that we can have the same rotation angle, but for example, the page is upside down. So I'm going to keep for this example simple case where we assume that we know the orientation and we assume that the page is up. Then we sort of put into place methods to adjust for all these other different cases. But for the moment, I'm assuming the page is up. Awesome. So now we have this angle. We have this set of polygons that all have the same rotations. Our idea was, well, can we find what is the rotation angle with the x-axis? And of course, trigonometry comes in handy in here. Probably we've all seen the triangle. We can find the tangent of this angle as the ratio between opposite and adjacent edge. And then using the arctangent, we can find the angle theta. Awesome. And you might ask, well, why am I looking at the longest edge? Just to give you an idea, well, often when you extract text, you can think of the short edge of the polygon as the eighth of the font, whereas the length is more like where the text, the line of text appear. So you really want to straighten up your text, the text line rather than the font. And also because when you go and compute the ratio between adjacent and opposite edge, probably having a longer edge instead of like a very short edge will give a more reliable estimate. And so basically our idea was then, well, we could go through the whole page and find the rotation angle for every polygon, but really we might just focus on the top few longest polygons to find the rotation angle. And here I'm just going to give a hint. So before I was talking about the fact that sometimes some documents might be on the same page, but they are on different angles. And probably studying how much, what is the variability in the angle on the page will give you an idea if one rotation angle is actually good enough or not, and if it actually will give you a reliable rotation or not. In this case, we know that all polygons are rotated in the same way, so that's fine. Awesome. So now what we did, we can build a function to rotate one polygon, so to rotate, to find the rotation angle for one polygon. Pretty much just trying to implementing this formula. So as I was saying, we can use the shapely geometry, for example, to import a polygon. And for every polygon, what I'm doing here, I'm finding the x and y coordinates. I'm using this function, which I haven't specified here, but to find the index for the longest edge. And then at the bottom here, I'm simply computing the opposite edge and the adjacent edge as differences between coordinates. So I'm finding this edge and this edge. And in the case when we have a perpendicular rotation, then this will be the way in which I compute the angle, so pi divided by 2. Whereas otherwise, we can use the arctangent of the ratio. Awesome. And just one thing, like here I'm returning minus rotation angle because by default, I'm assuming that I want to rotate clockwise. But these are all things that, as I was saying, depending on the orientation and everything, we can adjust. Great. So now we have the angle. Pretty much what we can do now is that, as I said, we can use the nth longest polygons on the page in order to find an average angle on the page. And then we could use the centroid of all the polygons to find that origin for the rotate method in GeoPandas. And what I can do now is that in this, we created this rotate page function, which takes in input a geodata frame. By default, I'm using the 3 longest polygons. And as I was saying, I'm assuming by default that the page is tilted to the left and the page is up. And I'm computing the origin as the page centroid and this angle in the way that I was mentioning before. And then we can use the rotate function to rotate all the polygons. And finally, we can find the rotated version of our page. Awesome. And as you can see, like it's not totally straight. So here there is another problem, which is the skewness on a page. Again, we build similar function that can solve that problem. So they can deskew the page, because that's another problem if you're looking for positional searches. So if now I try to reapply, the code below and I extract the passport details after I rotate and adjust for this problem, I finally get the right answer. So of course, this brings me to, there might be there's several set of pre-processing that you might want to check for your page before you do that. And I do know, and some people have suggested that TextStract in theory should also correct for that. So we are also looking into that, if we can get directly TextStract or Document AI to do this for us. But for the moment, this is actually, this is an idea using the spatial method and the boxes. The last thing that I would like to mention, and it's mainly to just like throw some ideas out there, and I'm happy to maybe have more discussions later, is thinking about the templates. Because what I was saying before, for example, imagine you're given a set of documents and you might need to be, for example, thousands, millions, and you need to detect recurring templates, for example, similar payslip types. And then you can build custom, sorry, there was someone that almost crashed. You can build custom extraction function for that specific template. Another idea, which I've already mentioned before, is, for example, we could detect, first you might want to detect the presence of a template on a document, say the passport or driver license, and then target the extraction for that specific templates, because you need to return all the personal details. So some ideas that we tried or that we thought about, well, when we think about similarity between documents, we can think, we can think in terms of the geometric layout. So, for example, where the words appear on the page, what is the shape of, the shape, not maybe the shape of polygons, but like where they are all on the page. For example, looking at several payslips, we can identify where more often the date or the gross pay or the net pay fields appear on different payslips. We can then think of similarities as well in terms of words. What I call stable words here. So for example, the idea will be given to documents, we can compute the overlap between stable words. So for example, after we remove names or numbers or things that are very person specific. And from what I've seen, computing similarities are like, you need to keep in mind that computing similarity using the geometric of the page is highly affected by rotation, by the skewness of the page, and by other problems. If the words are extracted correctly, definitely you might have a better match. And then to wrap things up, you could think of having an estimate, for example, using a measure to score how similar or dissimilar two documents are based on geometries, based on text, and try to cluster, what things appear to be the same template. So sort of like a document tagging. And I've thought about, for example, a score where you have very similar templates or very different templates. And here I simulated different different types of this payslip type and flexi time to see how these different scores would work. So this brings me to the summary of my talk, and I'll then see if there's some questions. I hope I convinced you that, automation can really help when you would like to increase efficiency, speed of those tasks which are repetitive, but they're still necessary. And I hope I give you an overview about all the different available the common OCR tools. And thanks, maybe I'll add the one that Gala also suggested, which I haven't tried myself, but I'm sure it will be good to have them here and they will be useful. And I've shown you how we can leverage the existing OCR tools, which sometimes tend to be general, to solve more targeted problems. And I've been mainly discussing deterministic methods using text and the spatial location on the page, but we are thinking, and of course, like machine learning driven approaches are also necessary in some cases and might help to solve more general problems, in particular for table extraction. And I've just briefly touched on the document tagging and templating problem, and this can be used as a pre-step before you, for example, you build custom extraction for specific templates. So this brings me to the end. So I'll now open up if you've got any question. And before I do that, I also would like to remember to, remember everyone that if you can look at other Eliiza brown bags, and in particular, a month ago, Anna, which we call Nushki, she gave a talk about graph theory in data science, where she touched on some application of graph theory to solve similar problems that I mentioned today. And feel free to send me any email or to know more about it. And thank you everyone for listening. Thanks, Gala. And I'm gonna see if there's any question.
I have a question.
Thanks,
Have you tried working with pictures where you have pictures on the PDF?
You mean images? So actual,
Yeah.
where your aim is to.
I've had PDFs that have, they probably, the way they were made, they have or they just have pictures. I know that the other PDF reader that I said kind of uses the fact of how a PDF is structured. So for example, like a scanned document wouldn't work.
Yeah.
But I've had PDFs that have images in them, and then that really quite aggravates the way these systems read it. Have you experienced that at all?
I mean, for example, even in some payslips or in other personal documents, like there's always some logos or things like that. I don't know if I'm maybe not understanding your question, but like normally they are not really, like, for example, text extract or document. They don't care about the images. They won't extract anything, and they will only extract, for example, the name if there's a name on the logo, but they won't care about the actual image itself.
Yeah, okay. I've dealt with some documents that kind of have images all across text, like text heavy, and then images around it. And that really fucks up the way that they get read.
Yeah, for example, with the passport example, if I run a passport and there's a photo, that's fine. Yeah, or there's like a symbol and it didn't give me a problem, but maybe there's like, If you said that you were using those Camelot and Excalibur software.
No, the Camelot and Excalibur, what they'll do is they'll read the kind of the PDF kind of code thing in the back, and they'll try and understand the table. If I remember correctly, but I haven't used them in a while. But what I tried to do recently was a document. It was kind of like a magazine, if you will. Yeah. And it just had lots and lots of text and then lots and lots of images. And,
okay, I don't know.
And then that upset the reading of the text. But I just wondered if it just randomly happened to me. It's very anecdotal, or if that's.
I don't know. Maybe try with the free version of Google Document AI, for example, and you see if it gives you the same problem. I don't know.
Cool, thanks.
Try that. No worries. When there is any other question, how do these methods scale? Question from Robert. Scale for large collection of photocopied documents. Would it get computationally intensive? So, as I was saying, like whenever you build some function to automate, you can always smooch the edges and make things more efficient, as well as we have been using it for large projects, like with thousands of a lot of documents. And it is true, initially things were a little bit slow, but we are now working to try, for example, to make things in parallel and to, as I was saying, including in some of the steps which do not involve extraction, include machine learning models, which maybe, they just need to be applied and they can make prediction fairly quickly. So yes, scalability will be a problem. Not a problem, but like something that we need to think about. But in terms of being computationally intensive, I don't think computationally intensive, because every task is fairly easy. It's more like the quantity that needs to be the quantity, so the amount of things that you might want to scale. Don't know if that's answered to your question. You're welcome. And if you think of any other question this afternoon, tomorrow, feel free to shoot me an email. Thank you, Marina. And thank you, Mitch.